Hi there, today I'm going to be talking a little bit about baking. So for those of you who don't know what baking is essentially the process by which we save in texture format information which has been calculated for a model. So many of you may be familiar with it in the sense of taking a very high poly model such as this one here, and if I turn on Y, as you can see really lots of detail in this model, taking a low poly model and essentially saving out the surface sort of shape as a normal map. And that is indeed one use of baking, but there are several others. I'm going to show you those. So without further ado, let's get stuck in. Okay, I have here in this scene a simple flat plane. Let me show you what that looks like in perspective. So it's just a flat plane with a texture applied to it. Now that texture is my UV coordinates, which is my unwrap as I've made it for a little cart. Now I'm going to show you the final result of this cart. It looks something, whoops, it's a bit big. There we go. It looks something like this when it's done. Now, I wanted to put on things like panels and stuff, and instead of using a height map or actually modeling it in on some of these sort of angled surfaces, I thought, well, I can probably do this straight onto a flat plane pretty easily. So here's my flat plane and my UV coordinates, so I know that where things are. Now I'm going to unhide all of the little models that I made. And we can see here some of these are fairly straightforward. Let's take a look at some of these panels here. So nothing too fancy, just straightforward modeling here. It can be as high poly as you like because that doesn't really matter. And we've also got some slightly more complicated details in bits like this, which if I turn wires off, you'll probably get a better feel for. So that's the kind of stuff that I'm putting on. These are all modeled a little bit above. If I look from the left, you can see the flat plane is this bottom one here, and they're all modeled a little bit above, as close as possible. But in this particular technique, it doesn't really matter too much how high up they are, because your model, your projection, which we'll talk about shortly, will just go straight up. But ordinarily, when you're making your high poly model, you do want it to be a nice snug fit to the target geometry, which in this case is just the flat plane. Okay, so how do we project the information that we've got here down to the texture so that we can save it out as a normal map? So let's pick this plane now. I've already set up projection, but I'm going to delete it so that we can go through the same process again. From the drop-down menu, we're going to go for a projection modifier. That's just this one here. Projection modifier has a whole bunch of stuff in it. We're just going to use a couple of these bits. So all I'm going to do here is use either I can use pick and click on them one at a time, but that'll be really tedious. So what I'm going to do is just use pick list and select all of the models in my scene. I think we need all of them, but you can do as many as you want. On the whole, you probably may even have attached these all, so there may even just be one object. That's fine too. So here's my list of objects that I want to capture in my normal map. There's one other thing that we need to do before we're done with the projection modifier, and that's say essentially how far do we want the projection to search for geometry, and that's defined by what's called a cage. Now you may see a blue line going all the way around this. If I scroll down to the cage, you can see we've got a few options. Push amount is the one that I use 99% of the time and rarely need to tweak afterwards, and in the case of just projecting onto a flat plane, that's absolutely fine. So all I'm going to do is push the amount up, and you'll see it rising up. Now this is kind of hard to tell exactly how high up it's going. We need it to be above all of our geometry, so for me to see that a bit more easily, I'm going to tick shaded. Now if I'll slide that back down again so you can see what's happening here. So it's gradually going above all of our geometry, and we need to make sure it covers up absolutely everything. As a little example, what I'm going to do is I'm going to slide it down a little ways so that I've deliberately left these what we'll call mist. It won't find these, and I'll show you what that looks like so that you can see if you've made this similar mistake, you'll be able to spot it as well. Okay, so that's the projection modifier set up. We can untick shaded now so we can see what we're doing again. That's about it, ready to go. So I'm going to go straight to the render to texture dialog now. We can get to this either from render to texture, which is just here, or just hit 0. A dialog box will pop up. Mine's just off screen. Sometimes it takes a little while for this to load, but it'll come up eventually. So what do we need to do in here? This is a big dialog box, but don't panic because we don't need to use all of it. Just a few things here. So First thing we need to do is tell it that we're using projection. So projection mapping, we're going to tick that to make sure it's enabled. If you've got several projection modifiers, then this is where your list of projection modifiers will come, but projection should be fine. 9 times out of 10 we want to use the existing channel. In the case of this plane, I haven't unwrapped it, but it's a flat plane, so the unwrap will be fine. So I'm fine to use the existing channel. If you have a choice here, make sure it's the channel that you want for your UVs. And then we get to the output rollout. Now, in this particular case, I'm just going to be making a normal app. So I will add to this list, and a little dialog comes up. I'm going to add a normals map and add elements. That comes up with some default options, which are not really suitable. You almost always want to increase this size. It is good practice to always go much larger than you need to and scale it down. So let's go all the way up to, well, let's go 2048, because I think my final texture size was 1024, so double is usually a good plan. So 2048, and it's usually a good idea to change the path of the texture. So let's pop that, I'll just throw it on my desktop for now. Okay, so save that, save it as a target. If you save it as 32-bit, then you'll also get your misses and things, so let's use 32-bit. That's it, so we can now hit just render, and we'll get a message telling us that we're not plugging it into a material. I know that, that's fine, I don't want to be bothered by that message again, so we'll continue. And we'll get what definitely doesn't look like a normal map. Don't worry, this is normal? Bad choice of words there, I guess. You just get kind of the lit up version of the objects in your scene. But hopefully when we've finished this, the final texture, which I'll open in Photoshop, will look like a normal map. So give me one moment. Okay, so this is the normal map that I ended up with. If I zoom in, you can see why I've gone to double size. You'll notice there's no kind of anti-aliasing or anything like that. It doesn't check for each pixel more than once, it just gets the middle of each pixel. So you get this quite hard edge, which at low resolutions looks pretty nasty. But if we go at a high resolution, scale it down, then that'll be fine. So I'm pretty happy with that. What I can do is I can then incorporate other normal map stuff, and the final result that I ended up with looked like this here, and that was just using other filters on photographs to get the rest of the normal maps, and that was about it. Okay, so let's move on to the next topic, taking a low poly model and making it look better by just using some turbo smooth and some other bits and bobs here and there. So here's the model that we're starting with. This was provided to me by a student on my course. There are a couple of bits that I thought could be improved by using baking to improve the normal map. The main thing I thought could bear some improvement was this really hard line under the hand, sort of upper handle, and these hard lines here, which I didn't think looked so great. And I also thought that would be a really uncomfortable handle to hold, so that could probably bear a bit of sort of smoothing off there. So those are the main things, but in addition to that, there's also some slight sort of triangulation issues here, where the highlight sort of doesn't move smoothly across the surface. So let's see if we can address those by doing a high poly model. So here's what my high poly model ended up looking like. This is the low poly here, and I'll just move that out of the way. And here's the high poly. So you can see I've tried to get some slightly smoother edges, still kind of hard edges, but not sort of perfectly sharp, not like you're going to cut yourself on sharp. So there's those, and you can see the handle's a little bit softer, something that I think would be more comfortable to hold, but not going too far away from the original geometry. So let's pop that back. Now in this particular case, we want our geometry to match as closely as possible, so they must be in exactly the same position, if at all possible. I decided not to bother baking out the two circles because they won't really change much, because a sphere is a sphere and you can't really do much more with that. So here we have just the low poly object selected, and beneath that the high poly. So let's grab the low poly. Always select your low poly when we're baking. I don't need this unwrap, I don't know what that's doing there. And you can see my projection modifier just sort of, the cage was quite a bit bigger than the actual model, but that's fine. rendered that out, and I'll show you what that came out like. Okay, so we came across a few problems. The main one was we were picking up details of other parts of the model which we didn't want. So that edge there and this sort of section here is picking up other bits, and you see these sort of odd little chunks and nuggets that we don't really want. You can tell because they just don't look like they're smooth. The peculiar triangulation is a result of me essentially making it all on one smoothing group. So if I hide everything else and we just look at this, you can see I've made it all one smoothing group, and for it to sort of fight back against that, it's kind of made a bit of a mess of the normal map. That's not best practice, but I sort of couldn't really be bothered to do this properly, so you'll have to forgive me. I didn't want to unwrap it again, and that's the main reason. If I'd have unwrapped it again, I would have separated out the material, the smoothing groups, so that they were separate, and that would have allowed me to keep them on different smoothing groups, but we'll talk about that a bit later, so don't worry if none of that made any sense. So how can we solve this problem where it's catching other bits? Well, this is actually a really easy thing to fix if you just know how. So what I'm going to do is I'm going to go down to the editable poly level, and I'm going to select this element here. I'm also going to select this one. Essentially, I'm picking elements which are likely to collide with other bits, and I'm going to set them to ID 1, and then I'm going to do Control-I to select everything else, and I'm going to set all of them to ID 2. And then in my render to texture dialog box, I'm going to, under projection mapping, choose options, and this gives us some even more options. And I'm going to tick hit only matching material ID. Okay, and that just means that this section here will not hit, allow the cage to hit any of these bits, because they're all on ID 2 and this is on ID 1. And when we do this, we get a much better result. And here's the result that we get. So you can see we've not picked up some of the bits that we were picking up before. So this is pretty much right. I didn't spend the time getting this perfect, but this will have to do. I then overlaid the existing normal map, which I'll show you what that looked like before. Whoops. With the layer underneath it. We can see it combines the two quite neatly. One little trick when you are using overlay is if you turn off the blue channel, then it won't overlay the blue channel, which sometimes gives undesirable results. So let's take a look at the final result. We ended up with this, which you can see we've addressed the sort of really hard edges problem. The light kind of moves across it much more cleanly. This isn't so hard and looks a bit more natural. Yeah, so pretty happy with this. A bit more time and effort could have been spent on it, but that was a real quick job. I'm sure if you use a bit of care, then you can come up with even better results. So let's move on to the next thing. Okay, so in this case, I'm going to take a high poly asset, which is this here. I've already actually crunched this down to a lot fewer than it was when I grabbed it from ZBrush, but it's still very, very dense. And just to make it easier for me to work on, I reduced that even further to this model here. And then I started making the low poly version of it. I think I'll probably just leave that for another quick tutorial at a later time. So once we've got this low poly version, what we can do is we can just grab our high poly version. Let's put them one on top of the other. Oops, that was not where I was expecting it to go. Let's move that over there. So this is our high poly version and our low poly version. I'm going to color these differently so that you can probably tell them apart a little easier. Okay, so the low poly model is in red. Right, again, we've set up a projection modifier. I'm not going to show you that again. And set it up in the render to texture dialog to get our normal map. Nothing too fancy there. From that we got this result, which is looking pretty good. So what did I want to show you in this? I want to show you baking down ambient occlusion in this little video. So instead of using a normals map in the output, we're going to use a different map instead. We're going to add, and we're going to use a shadows map. And again, we're going to go as high resolution as we can get away with, so 1024 This one will take a lot longer, so going straight to 2048 will be expensive. I'm not sure how these got disabled, but let's turn these back on. And under options, make sure ray mist check is on in case you miss anything. That was something I'm sorry I forgot to show when I said I was going to miss that curtain earlier on. I forgot that. Whoops. Let's see if we can spot it here. Right, so that's all set up. And because what we're doing is going to be obstructed by shadows and whatnot, so we're going to actually just pick our two objects and hide everything else. Okay, so we've got in here simple setup, just the skylight there. Got to make sure that if we to get the effect we want, the skylight itself, which if you don't know how to add that, that's under lights, standard skylight. Just drop one in. You don't need more than one. Doesn't make any difference having more than one, so don't bother. And I'm going to use multiplier of 1 and make sure that cast shadows is on. And for this, I'm going to be using the default scanline renderer. You can of course use other renderers. That's fine too. There's one other thing that we need to do before we start, and if you get big shadows across your map, this will be why. We need to go into the object properties of the low poly object and just make sure that cast shadows is unticked. By default it will be ticked. I've already turned this off because I've done this render before, but you just need to untick cast shadows because we do not want to cast a shadow onto our high poly object. We don't want to cast a shadow from the low poly object. We do want to cast a shadow from the high poly object, of course. So leave that as it is. So that's all ready to go. Let's run a render and see how that goes. Okay, so even with that set to just 4 rays per sample, that still took ages. That's just the nature of skylights in the scanline renderer. A couple of bits of interest. You'll notice the odd little red pixel here and there. Those are what we call ray misses. Because I had my renderer set up under options, ray mist check, ray mist color red, it's just identifying any bits where the cage isn't big enough. So I could solve those problems by making the cage just a little bit bigger. Okay, I'll show you what that would look like. I just increased the amount by a little bit more. The more you go, the less accurate and the more kind of wavy your render will be. So try not to go any further than you have to with the cage. Keep it as low as possible. So now I'm going to just pretend I've rendered that out high. I'll show you the end result when I'm done. But I would have rendered that at 10 rays per sample or more if you've got the time and patience to wait for longer. And then I do one other render. So this is what I've just done there is what I call a sort of true ambient occlusion render, where it's light from all around without any kind of top heaviness to it. What I do after that is, if I unhide all, you'll probably have noticed I've got a kind of bucket thing going on here. So I select all of these and then hide unselected. So why have I got this in a kind of bucket? On the whole, most props, most characters in games have light cast at them from above, and we're used to, in everyday life, kind of seeing that. So we kind of expect it, because you're outdoors, the light's coming from above. You're indoors, most lights on the ceilings, light's coming from above. So it's pretty typical to see light coming from above. So all this is doing, by having this bucket here, is it's meaning that the skylight, which, remember, the light won't actually be coming from this little gizmo here. It'll be coming from all around the world. It's just going to get blocked from a little bit from the sides and blocked from below, which will give it that kind of top-down nature to it. So then I'd hit render again, and I'd save that as a different file. Now let's take a look at what those kind of look like once they're done. Okay, so I'm in Photoshop now. This is the directionless sort of true ambient occlusion render result when I did it at a higher level. I think I might have played around with the levels a little bit here, so I might have changed this, but ultimately you'll get something roughly like this. I think it looks like I've brightened it up, I think, but otherwise there's probably no huge changes. And let me show you so that this is the top-down result. So you can see here the difference between the directionless, which is coming even from below, and the top-down, which obviously is highlighting the top of his head and his face and the top of his shoulders a lot more than the directionless version, which is sort of highlighting everything all at once. So what I would typically do is I'd kind of mix the two together. to a level that I'm happy with. So I think I settled on about 85% or something. So it's mostly top down, but you know, you've got the facility to choose whichever you prefer. I have a color underneath this. Now I think I set this to soft light, so you can see I've kind of given a purplish color, and that's, you know, a good starting point for your textures. There's one other final thing that I do. I use Crazy Bump, which you do have to pay for, but so if you don't have that, you might have to find another solution. But I really like Crazy Bump, so I'd say it's worth the money. And I simply load in the this was the final normal map that I ended up with. I would copy this, go over to Crazy Bump, which is too big for my screen right now. I would copy it again because it's fighting me. There we go. Paste normal map from clipboard. And this is again far too big. In fact, we don't even need that preview. And I would go over to diffuse, and it would take a guess at what the diffuse should look like based on the normals that I've given it. And you can play around with these sliders to get different results. You can increase sort of things like crevices and stuff to get different things. Or you can also use occlusion. That's another nice little one to play around with. So if you increase the detail a lot, you get more sort of popping of the details, and that can really help. So those things all come out of Crazy Bump and gave me, oops, that's not at all what I want to do. No, no, no. Gave me, let's make these 100%. There we go. Gave me this and this, which I think I used a multiplier on these guys. Wherever multiplier's gone, there we go. And got a result something like that. And that was my starting point for my texturing. And you can see a lot of the work has already been done for me. So that's good. And it also completely matches the normals. So everything's all very harmonious. I then did some more painting and ended up with something like that by the end of the day. So you can see a lot of the detail in my final texture came from just baking the normals that I'd already made. So yeah, very strong workflow, I think, very time-saving and accurate. Good, so let's move on to the next thing. Okay, so I've got in this scene two characters, well, it's the same character twice. One of them is the highpoly character, which has been textured. If I show you the texture sheets for this guy, this is two texture sheets. So one is the face, sort of all the skin areas, trousers, boots, and hat, and a couple of other little details. And the other is more like kind of accessories and jacket and shirt. So there's the bag there, and this sort of the utility belt and other bits and bobs. So they're on two separate texture sheets. Okay, that's important to remember. The low level of detail character that I have to the right of him, obviously very similar sort of looking geometry. It should sort of be the same silhouette, but this is much, much cheaper. This has gone down from, let's see, 9,000 triangles to just 2,000 triangles. So a lot cheaper, this model. But significantly, it uses now just one unwrap. So one texture. So where this one was using two textures, this is now using one. So obviously, in addition to the changes in the geometry, we have a huge change in the UV layouts. And a few other features to note which are interesting are things like these kind of accessories that are on his wrist, which are modeled, are not modeled over here. So that's a big difference, as well as just the general bits and bobs here and there, things like the buckles and stuff that just aren't modeled. So there's big changes in the geometry. What we're going to try and do is we're going to bake all the information here. That includes the surface direction, which is obviously the normals, as well as the color information into this guy, so that we don't have to start for his texture again or start sort of photo manipulating the texture into a different set of UV coordinates. So potentially quite a sort of difficult thing to do if you're not using baking, but actually when you're using baking, it's really, really, really easy. So put them on top of one another, so as close as you can get them. Set up a projection modifier, just as you would normally. Set up the cage, all the rest of it. I'm not actually going to go through this because I've already done this once, and there's a couple of other little fiddles that I had to do, I think, that you already know how to do now. Things like setting up different material IDs to not catch other things, stuff like that. And I would have also gone in, probably, if you click on cage and start, you can move around just certain parts of it. So you can select these bits, say on both sides, and increase the push amount just on those bits. And things like that I might have done to just tweak the cage to be as good as it can be. So I'm not really going to do that just now. I'm just going to show you the theory of how you would go about doing this. So open up the render texture dialog again. And when we add to the output, we're now going to add the normals map, which we want to do to capture the surface direction. We're going to add that. We're also going to add a shadows map. No, we're not. We're going to add a diffuse map. Because, sorry, we've already done the shadows map. We've already done an ambient occlusion bake, which I can show you in the texture as well, if you like. But diffuse map, add that. And I would increase the size to be, in the case of the normal map, twice the size of the final resolution that I want. In the case of the diffuse map, you can probably get away with the same size, but can't harm to do twice the size as well, just to get sort of softer edges. And then hit render. And what you would get if you clicked on one of them, hit render, clicked on the next one, hit render, is two different textures, which hopefully would look like your final map. So the textures I ended up with are, if we compare them with the original textures, they look pretty much the same. You can see some details have changed. So the eye is now sitting as part of the model, so it wouldn't be able to move up or down or anything. All of these sort of wrist accessories, which were separate objects, are now baked into just sort of the arm, one arm. The other arm is sitting over here. And the buckles are also to be found part of the texture, where before they were, not part of it. So it's baked lots of stuff down into the completely different UV arrangement, which suits my low poly character much better. So you can really just change everything a lot, and it's absolutely fine to do that. And this bake takes no time at all. So it's a very nice workflow. And the best bit is you can hardly tell the difference. So this is the 9000 triangle character with two 1024 textures, and then on the right hand side we have the 2000 triangle character with one 512 texture. That's baking down for low level detail characters. Finally, I want to show you some tips for getting the best out of your bakes. These are not tips for using PowerPoint. I am fully aware this is not how you use PowerPoint, but just let's skip over that. So always bake at higher resolutions and scale down. I've already mentioned this a couple of times, but it is really important that you try and stick to this. Do your own little experiments if you want, but I think you'll agree that it is always better to do that. UV pad changes in normal directions. Now that sentence probably means absolutely nothing to you right now. So let me load up some examples. So here we've got a kind of a dice shape. We're trying to, this is the highpoly. We want to make a basic cube look pretty much like this. We've got two cubes here, and both of them are pretty much the same, but for one small change. On this one, we have our UVs, the seams are together. There's no padding between them. And on this one here, I'm sure you can guess what's coming. All the different faces are separate from one another. This is particularly important because they're all on different smoothing groups, which means naturally these have a great difference between their normal direction from this face to the one next to it. And if we look at the texture after I baked them, in the first example, what's happening is it's changing direction very strongly, but this seam is right here, so it's lying right on this edge, and what's happening in the final result when we apply it is it's not perfectly picking up the right part of the texture on there and anywhere that there's a seam, because these are right next to each other, and it's just slightly grabbing the wrong part of the texture, and you get that horrid sort of line, whereas this one doesn't suffer from that problem at all. And if I show you what that one looks like, you'll see there's enough padding. The actual UV coordinates probably only go out, say this far. So there's padding around it, so there's no chance of it getting a color which is slightly incorrect in any way. It'll absolutely definitely always get the right color. That's why we have padding in our textures. So yeah, there's that. Next thing, avoid shapes which project perpendicular to the surface. So by that I mean, here I've got 4 little shapes. I've colored them all the same, but maybe if I color them slightly differently just for a moment, you'll see I've got a basic cylinder and a basic box. Then I've squashed in that top face of both of them. And I'm going to change it back to the same color because I want to show you why this isn't such a good idea. If I look at this from the top, which is exactly what a projection modifier is going to be doing, there's really no face for me to pick up. This here of the low poly is pointing straight at me, and so is this. And I can't see any of the edge around it. I'm just looking straight down on it, and that's exactly what a projection modifier would do. Same thing applies here. But if we look at here, now this is interesting. We've got a surface which is sort of pointing away up and to the right, away up and to the above to the top, up and to the left, and up and to the bottom. Same here, all the way around. We've got this direction that the surface is pointing. We can see that surface, and it's pointing in a different direction. We just simply can't see the sides of this. So avoid having stuff which is perpendicular to it. I didn't bother rendering this one out. Probably wouldn't be very interesting to look at. I think that should make some sense to you anyways. So there's that. Avoid very tall and deep shapes. The reason for that, you may have spotted on these here, if you've got tall or deep shapes, such as the ones to be found over here, these are very deep. And as a result, you get this kind of skew, and that will happen, unless you take great care to avoid it. That's pretty much guaranteed on tall and deep shapes. The workaround is actually to use the technique I started off with, which is to use a flat plane. So render out whatever you need to of your high poly to begin with, but leave details like that to once you've done that, and then use a flat plane and place those on the flat plane, and that'll always get things straight and neat and tidy. So yeah, just refer back to that bit at the beginning of the video where we had a flat plane and we were just placing our geometry on top of that. That will never result in any kind of skew. So that's one advantage of that flat plane. What else do we have left? Oh yeah, don't forget that you control the normal direction through vertex normals too. The normal direction is a result of the vertex normal plus the normal map. So a vertex normal usually is controlled through smoothing groups, but in this particular case I made a box which I've edited the normals so that they point out in different directions, and this is just a simple box with a chamfer on, and I've just changed the vertex normals to point straight out in the same direction. That ends up with this pretty good result, and it doesn't need to do any of that sort of the edge bits in the normal map, which looks like this here. It's just the holes, and these were straight because of the because I baked those onto essentially a flat plane. That's why those aren't skewed like like these ones are. So yeah, those are pretty much all the tips I've got for you. I hope you found this video helpful, and I hope you're able to get as much as you can out of your bakes now, and think of using baking for some other stuff, even things you might not think of, such as rearranging your UVs of the exact same model after you've textured it. Things like that are possible using baking. You just need to sort of think of some of the other applications of baking beyond just making normal maps, because there are many and they are bountiful if you know what you're doing. So best of luck with it. Thanks for watching.